when I got my first car, it was straight into carrying out modifications and things like that to try and go faster, because every 17-year-old boy needs to go faster in a car. It makes perfect sense. Why would you want to go slow when you can go fast?
Hey everyone, you're back with Alex and John for another episode of Tech Society. In today's episode, we speak with Michael Tuckey, founder of New Forge Engineering, an advanced additive manufacturer right here in Western Australia. Michael has an interesting entrepreneurial origin story, getting started in the world of street drifting, starting as a passion project and eventually establishing a business that will fulfill increasing demands for 3D printing. As COVID-19 fractures the economy and brings entire industries to their knees, there's never been a better time to bring manufacturing back to Australia. We pose Michael the question, will additive manufacturing give us the competitive edge we need to take on this monumental challenge? Thanks for agreeing to join us today.
Thank you very much for having me. It's a great opportunity.
Yeah, no worries. Well, I enjoy the stuff you post on LinkedIn, and it's good to see people talking about manufacturing in Australia.
Really cool stuff. Yeah. And it's all very relevant. It's about games. It's about music, electronic music. Things that are close to our heart.
Oh, fantastic!
I love
I found it really interesting. Your thing here, actually, we should just jump straight into it because I do want to ask you about this.
Yeah, absolutely.
I'm looking at your LinkedIn post about the controllers. Actually, I think it's an Xbox controller.
Yeah.
Really cool stuff. So I'm guessing like a lot of your work at New Forge is basically revolves around the potentials of 3D printing. Yeah,
absolutely. So New Forge, what we are is a service provider for 3D printing. So we utilize some of the latest in additive manufacturing technology, and we provide that as a service to people. So
can you define, because traditionally you got CNC machines, which is subtractive.
Yes.
So 3D printing is additive. So what are the disadvantages, advantages of either technique, I suppose?
Yeah, so I'll give a brief outline of what the two are. So as you mentioned, subtractive manufacturing, that's what we would consider traditional manufacturing. And for that, the way that works basically is you start off with a piece. So say if we're working with something, making something out of stainless steel, we start off with a chunk of stainless steel, and then we'll remove material until we're left with the part that we want. So we're drilling holes, we're machining surfaces, milling areas out, that type of thing. With additive manufacturing, which is commonly referred to as 3D printing, you've got a machine that comes along, and instead of removing parts, it adds parts, and it adds only the material that you require, essentially. So some of the advantages of that are that you can manufacture parts that you might typically not be able to manufacture with traditional methods, or be very difficult to manufacture with traditional methods. So if we think about, say if we had a small cube and we wanted to have some complex either airflow or water flow type ventrices going through it, that might be quite difficult for traditional manufacturing to do, because usually drill bits don't like drilling around corners, things like that. Whereas with additive, you can just add your material layer by layer, and details such as that aren't significant at all for additive manufacturing. It's just that's really the strengths of it.
What about, because I've looked into 3D printing a while back, and one of the disadvantages I found was that just the time to print can be pretty slow.
Yeah.
We're talking like overnight, basically, every time for a single unit. Is that right?
Yeah. Well, it's greatly dependent on the size of what you're printing, because most machines will have a maximum throughput. So there's a maximum extrusion rate. So one of the ways I like to describe 3D printers for people is, say if you had a toothpaste tube and you come along and you squirt toothpaste out in a circle on your kitchen bench, and then you come along and you squirt another circle onto that one, and you just build it up like that.
Yeah.
So the machines are limited by how fast they can extrude the material. So if you're making something quite small, say a 2 centimeter by 2 centimeter cube, you might be able to do that quite quickly. But if you've got the equivalent machine and you're printing, say, something that might be 50 centimeters by 50 centimeters, and that's going to take a lot longer because your maximum extrusion rate is whatever it is.
Yeah, it's just based on volume.
Yes.
Yeah.
One of the advantages with 3D printing, however, is that once the operator has started the operation, it's complete hands-off. So what we do at Newforge, and anyone that's 3D printing, like you said, you start it, and then it will continue manufacturing throughout the night, through the weekend, that type of thing. It's completely hands-off from that.
Less supervision. That's cool.
Yeah, from that approach. So the good thing about our machines is they happily work all weekend and all night. They don't complain.
Overtime.
Yeah, right. They even work public holidays. And
That's
yeah. So they're not really fussed about that. So that's a good thing about it. But yes, time is a key limitation with additive manufacturing. One of the other advantages, however, is the scalability of say, the model that we employ at Newforge, where, say, we've got 5 machines now, we can have them all running simultaneously.
Of course, you can scale them up,
Yeah, should we
That's right.
Require more throughput, it's just a case of purchasing more machines. I say that like it's, the machines are free or really cheap. That's not the case. But it's a very, very easily scalable model. Because,
it's linear and it's unbounded, so you can basically keep scaling up. That's cool.
Yeah. And the software side of it, the software that controls the machines that we utilize, it's all one system, and all the machines are integrated into that. So you can say print a part. Say if we want to print a mount for a picture frame or something like that.
Mm-hmm.
We can set up the file and tell the system, all right, well, let's have printer 1, 2, 3, 7, 6, 9, and 2 print that part, and you just press go, and then the machines will just do it.
Oh, so it's like a clustering system, basically.
Yes.
Very cool.
Yeah, it's really cool. So, and the and you guys actually use metal and carbon fiber
because commonly it's PLA and ABS stuff, right? So does Newforge use metals as well?
One of the mainstream misconceptions that the general populace has about 3D printing is based around what they've seen, and what the general populace will see is just small desktop hobby type printers that are quite cheap and affordable, which is really great. However, there is a rich history of industrial 3D printing, but as it's in the industrial and medical type sectors, the general public don't really see that. These are multi-million-dollar machines. So the misconception, one of the misconceptions the general public have is that the printed parts are made in cheap plastic at a low quality. So that's one of the keys to my marketing at Newforge, is to show that that's not the case entirely for 3D printing, and that there is this industrial side where parts and things can be printed at an extremely high quality and extremely high strength. So the machines we utilize, there's 2 sides to them. Well, there's 2 different types. One is a system that prints in metal, and the other is a system that prints in nylon with carbon fiber.
Cool.
So like composite parts.
Yeah.
Yes.
Right.
Yeah.
And they must be super strong.
Yes. Yes. So
and accurate, I hope. So it's like, because I noticed a lot of the 3D printing, like it's considered, you're right, it's considered a kind of hobbyist venture where they build little figurines or they print out plastics and they run some acid on it, but it's not sound enough for, production.
Yeah, absolutely. So one of the really parts that really impresses me about the systems that we employ, the carbon fiber ones, for example, what they're able to do is lay continuous strands of carbon fiber through the parts. So, for example, if we were printing, say something like, if you think about just a 30 centimeter ruler that you'd have at school, if we were printing something like that, we would lay the 30 centimeter ruler laying on the print bed, and you just print up layer by layer. As the layers go up, the machine can lay continuous strands of carbon fiber. So if you think about it like a fishing line, but made of carbon fiber, it lays that through continuously as the print is printed. And then on the two axes, on the X and Y axes of your part, you're able to achieve a strength that's comparable to steel with a weight in your end part that's less that of aluminium, sometimes down to half that of what an aluminium part would be.
Wow. That's interesting. Very interesting, yeah.
Yeah.
Because normally you have because molding carbon fiber is very hard in my experience. So you've actually created a way to make carbon fiber, or the way you're working with it is it's malleable. So now you've got the advantages of metals, but in carbon fiber, right?
So you're saying there are limitations though?
Yes. So one of the limitations with that is if we talk about the strength properties of a material, generally, say if we had a block of steel, we would say that the strength properties of that they're isotropic in nature. So that's the same strength on all the different axes.
Yep.
Whereas with the carbon fiber printed parts, they're anisotropic, which means on the X and Y axis, they're extremely strong, but on the Z axis, that's going up and down, the carbon fiber isn't laid in the Z axis, it's laid on the X and Y axis. So on the Z axis, so if we're standing in front of the machine, the Z axis is the top, from top to bottom of our part. The strength of that axis is the polymer bonds of the nylon.
Right.
So to take advantage of that system, you really need to be designing for it. And that's where the practice known as DFAM comes in. So that's an acronym for Design for Additive Manufacturing. And that's a new avenue of industrial and mechanical design now that people are
pursuing
pursuing.
So the carbon fiber, would I be right in thinking a lot of that would be for car parts or at least?
I would have imagined drones as well.
Drones,
Yes. So there's actually a drone company in New Zealand that utilise these same machines for the production of their drones.
Very cool.
There's also a robotics manufacturer in Las Vegas called Huntington Dynamics, and their robots are made entirely on these same machines. So it's an interesting case actually, because they have robot arms. They're industrial robot arms, and they're about the sizing of them. The whole unit, if it's standing up, is about 1 meter high, the arm, and they've got a maximum load carrying capacity of around, I think it's around 4 to 6 kilos or something like that. So that's the kind of size of robot they are. So this company were using these machines for prototyping of their robots. Now, when they went to scale up their manufacturing and go into production with these robots, they were looking at naturally you start to look at injection molding. So to facilitate injection molding, you first have to have your tooling produced, and that's renowned for being quite an expensive venture at that point. Not only that, is that once you've produced your tooling, you have to then commit with your manufacturer to minimum orders. So as the story goes with this company, Huntington Dynamics, they were looking at somewhere in the order of $4.5 million to go into production. That's just to cover tooling costs and that first minimum runs with the manufacturers.
Yep.
And instead, what they did was simply scale their additive manufacturing side and just created their own mini factory, basically, because they were already getting the quality and the strength and the accuracy they needed from the 3D printers. And it was just a simple case of getting more of them and then setting up a micro factory.
It's funny because the concern is always like hard to achieve the kind of volume that you get with injection molding. But if you already spent $4.5 million on 3D printing hardware, you get pretty high.
Yeah, you're going to get quite a few 3D printers for $4.5 million.
Exactly.
Yeah. So there's back in a few years ago, and I think you still will hear it now, every now and again, people will talk about 3D printing like it's the be-all and end-all of manufacturing. Mm-hmm. And a lot of people that are really close into it, like myself, are of the opinion that that's not the case. Not anytime soon, that's for sure, because there is those speed limitations. I don't know if you've seen an injection molding machine working, and the rate that they can
amazing.
Expel parts is unparalleled. So there's always going to be a place for traditional machining methods such as milling and CNC and injection molding and all that kind of stuff. Mm-hmm. 3D printers and additive manufacturing is just another tool in that toolkit of manufacturing, albeit a very powerful and really well scalable one.
And that's it's going to play a big part in bringing manufacturing back to Australia, isn't it?
Yes.
Yeah, because just to add to that, we had a podcast recently with Dirk Fainoa, and he saw 3D printing as a way to reduce our reliance on manufacturing overseas. So you'd be able to basically share design files and manufacture locally. And that's kind of the future of 3D printing. And
there's more.
What are your thoughts on that?
Micro manufacturing. So you set up mini factories and only to distribute within 10 kilometers or something.
Distributed, decentralized manufacturing, I guess you can call it.
Yes, yeah, absolutely. And the great thing about that is that one of the key things I think about for Australia in particular, and it's also for most first world countries such as Australia, New Zealand, the US, parts of Europe, where we're reliant on manufacturing from countries such as China and India, because they have the advantage of the labor there being extremely cheap. So they're able to have that leverage over us, that they can produce parts orders of magnitude cheaper than what we can. Now, as I alluded to earlier, the machines we utilize, they work 24/7, and outside the running costs of the machines and the initial purchase costs, there isn't a labor charge that goes along with that. So with technology such as this automated digital manufacturing, we're able to take back that advantage that other countries have, because we're not relying on as much human labor. There is still human labor involved, but nowhere near the amount that of other manufacturing methods. So what it's going to enable us to do is really take back a chunk of that manufacturing. And one of the great things about it is what I mentioned earlier about it being scalable as well.
I noticed that it's more of a higher skill labor because you need guys managing clusters of 3D printing machines. And also, in terms of reliability, do you find that at a certain point, 3D printing, what it outputs is something that is consistent, reproducible, reliable, like what traditional manufacturing provides already? Or does it tend to have a high failure rate?
It really depends on the quality of the machine that you're using.
And that goes both ways, right? Like even the traditional manufacturing, it's the quality of the machine.
I was just seeing. I did a lot of research on 3D printing when it was like becoming popular, and I think one of the issues was inconsistent heating plates, slight, and then the model's slightly wonky, and then everything just breaks overnight. So that kind of stuff. Is that a problem that still exists today?
Yes and no. So an interesting story I like to tell is when I first got into 3D printing a few years ago, I bought myself a low-cost entry-level machine. And I had what I like to call a 99-1 relationship with that machine, where I would spend 99% of my time trying to make the thing work, modifying and upgrading it, because that's just part of how I like to do things. But the majority of the time was trying to make it work and troubleshooting it, and spent inside this really steep learning curve of operating a machine such as this. And 1% of the time was actually printing with it.
Yeah, I get that.
Yeah. So absolutely, that is a case if you're engaged with a machine that is of that lower cost,
residential
side. Yes, like a residential machine.
Yeah.
However, when you're working with industrial machines, they're on the other end of the spectrum. So, in multiple ways, obviously the price you're paying accordingly. You're getting what you pay for with everything. It's the way things
the world
work.
works.
Yeah. So there are you still have failed prints every now and again, and it does cost money and it costs time, but nowhere near the amount that you would be seeing with a low cost economy style machine.
So it's a manageable risk, I imagine, and
yes.
And I would say that
you're expecting it and you can handle it.
And the error rate would still be less than overseas manufacturers, just with that distance of quality control and communication.
It's true.
That's just a segue quickly. So you became involved in mechanical systems, being involved in the Australian-Japanese performance car scene. I'm reading here, which that's really cool.
Pretty cool. Yeah.
Tell us more about that.
I was a big fan of Initial D, so I'd love to hear more.
Oh, yes. As was I at that time.
I'm completely ignorant. What's Initial D?
It's a huge show that was popular back when I was in high school. It's just about cars drifting around. It's a Japanese show. So, cool. Yeah, tell us more, Michael. I got to know.
Yeah, so I, like many young men, when I reached that ripe old age of 16, 17, got my driver's license, suddenly got interested in cars. As someone with a mechanical, electronic type background, I was instantly enticed by the possibility of modifying things to make things go faster and become more efficient. So that goes hand in hand with cars and performance cars. So basically, from when I got my first car, it was straight into carrying out modifications and things like that to try and go faster, because every 17-year-old boy needs to go faster in the car. It makes perfect sense. Why would you want to go slow when you can go fast? So I grew up in the southwest of Western Australia, down in Albany, and that's a small. It's classified as a city, but it is basically a small country town. From that point, there is not a great deal to do for the young people. There might have been, there's like one nightclub that you would go to, things like that. And a big part of the culture down there was when you got to that age, you'd get your fancy modified car and you drive up and down the main street with your windows down, your music playing, and if you were lucky, there might have been an attractive girl next to you. Yeah, maybe not so in my case, but that was the kind of thing we would do. So that this was when would this have been? Around the early 2000s. From that point in Australia, in Perth, if we go forward to around 2005 through 2008, the Japanese cars became, modifying of the 90s Japanese turbocharged sports cars became quite a big thing in Australia, Australia and New Zealand. And a lot of that was revolving around the drift scene. So for anyone that's not familiar with what drift racing is, basically it's a form of racing where the winner isn't the person that comes first. The winner is determined by a judge who's observing the race, and the parameters that the judge is judging from is how well the driver is able to slide their car through a corner, what sort of angle they're able to achieve while still maintaining control of that car, how much smoke they're able to produce from their tires in the process.
Yeah.
And so basically from an ignorant onlooker's perspective, it would basically be how reckless someone is able to move their car through a course.
and waste good tires as well.
Yeah. There was a couple of high profile tragic motor vehicle accidents in Australia within a short period of time. This would have been around 2007, 2008. There was a bit of a public outcry around this kind of driving, and Australia soon brought in some new laws, and now known as the Hoon laws.
Of course.
Now, from that point, police had new powers and extra resources to enforce these new laws. And almost overnight, our company was severely impacted by this because our customers started were impacted heavily by these laws, and rightfully so. If someone's breaking the law, then they're breaking the law. I'll give you a brief outline of what the Hoon laws were. Basically, if someone was deemed to be driving in a reckless manner, and they were caught by the police, the first offence would entail the car that they're using be confiscated and stored for 24 hours. The offendant had to fund the towing of the motor vehicle from wherever they were caught, side of the road, to a storage facility. They had to pay for the storage. They had to pay for the car to be towed back to their house. And then they also get fined and they're dealt with for the incident as well. Now, that's the first offence. Second offence is the same thing, but the car is kept for 2 weeks, and the offendant's paying the storage fee for that vehicle for that full 2 weeks. And the third offence is they just keep your car, and then it just gets sold off auction.
It's auctioned, right? Yeah. Oh, and I think some of the more high profile ones, they crush them.
Yes. I'm not sure if that happened in WA.
I think it did, because I seem to remember that a friend of mine from way back then had his car crushed, and it was like
that would have been.
He put like $80,000 into that, and
that would have hurt my. That would be so depressing seeing your car get crushed.
That's right, and then they did it for that emotional impact, because normally they would obviously auction them, but anything they deemed kind of too hoony, it just crushed it in front of you.
And the sad thing is, he's probably still paying that car off now.
Oh man,
probably.
yeah.
Really.
Well, I always wondered how he afforded it because he didn't have a great job and he didn't deal drugs. So
yeah. Well, the way that a lot of guys were affording these cars was just through finance, just through banks. Yeah. Because this was also in a time when the boom was starting to ramp up as well.
Of course.
So there was a lot of money flying around in Australia at that point, particularly in Perth, because we were right in the epicenter of that mining boom as it was ramping up in this point.
Yep.
That and a lot of students and international students that were well funded from their home countries, so to speak. Yeah. But yeah, it was a extremely fun and interesting time for us. But as our business was impacted so heavily, because it was like overnight, the police were using helicopters, and they were able to, they had cameras in those helicopters, so they could take a photo of someone driving recklessly, have their number plate in that photograph, and then the person, who was drifting or whatever on the street would then just go home, go to bed. The next day they have a knock on the door and there'd be a court summons, and they would no one would even know, because when you're driving a car, you don't realize at night you're not going to know if there's a helicopter up in the sky watching you. So it was seemingly overnight. Our client base just disappeared. And I think from that point, the business was gone within a couple of weeks.
Well, I think the entire industry would have been killed off at that time. So even today, drifting is not as big as it used to be. I did remember it was huge back then.
Very specialized now, and all centered around a racetrack, which obviously makes it a lot more expensive for people to practice.
Yeah.
I mean, it's very analogous to COVID-19, right? Law comes in, shuts down your industry. Suddenly you're, what now?
Yeah.
How's that affected Newforge, actually? The whole coronavirus pandemic.
So this was really, really interesting in one respect, terrifying in others. But whatever hard times we're facing at the moment and continue to face with our companies, I will always say to my business partner, well, at least we didn't just start a restaurant.
Of course.
Because there's plenty of people out there that are in much worse situations than what we are.
Yep.
And, I spent some time in hospitality. I know what that's like. And it's just absolutely devastating to see the job losses involved. And, I'm sure all our hearts go out to those people affected.
Absolutely. Yeah. Have you noticed a renewed interest in, Australian manufacturing? Not necessarily converting to sales, but at least, people asking the question. Is a lot of people we've talked to are talking about it. I don't know whether they're actually accomplishing anything, but the conversations seem to be happening. And pre-COVID-19, no one is talking about it. It was kind of a, pre-COVID-19, people almost had they were very fatalistic about it. Like, no, manufacturing in Australia is dead. And, now they're saying, oh no, we need to bring manufacturing back, and we need to figure out how to make it cost effective. And I think additive manufacturing is obviously a big key in that. It has to be.
Yeah. So that's so what you mentioned there is people talking about manufacturing being dead in Australia, and that's that was the opinion I had as well from from one perspective, and it was partially misinformed, but it was easy to come to due to the the two high profile cases of Ford stopping production of the Falcons in Australia, and GM stopping production of the Commodores, and then completely pulling out of Australia entirely,
killing the Holden.
Killing the Holden brand. So those real big high profile cases really started to cement that idea in the Australian, the average Australian's mind. But in saying that, there is still a lot of manufacturing that goes on in Australia, and there's still large amounts of revenue that are generated for this country through manufacturing. So, for example, the company ResMed, they make ventilators and CPAP machines. So CPAP machines are continuous positive airway pressure machines for people with sleep apnea and things like that. Medical devices. ResMed are a medical device company. They're an Australian company, and they manufacture in Australia and they distribute worldwide. So there are a lot of companies like that in Australia that they're not on the forefront of the general public's mind when Holden and Ford really are and were. So, but yes, there was a slow sort of beating of the drum in regards to bringing manufacturing back to Australia, and now in this COVID-19 affected Australia, there is suddenly a hell of a lot of more drums, and they're being beaten a hell of a lot louder than what they previously were. And especially in the 3D printing, additive manufacturing space, there is a huge amount of talk and movements around that. There's been some fantastic initiatives from various bodies, such as the AMGC in Australia, and that's the AMGC, the Additive Manufacturing Growth Centre, and that's a non-for-profit organisation that works with the government in generating and facilitating the growth of the additive manufacturing sector in Australia. They set up a manufacturing response register in would have been late March, I believe. And what this register was basically was they put a call out for any Australian manufacturers to register what their capabilities are and their willingness around manufacturing for COVID-19 relief. So what we've all seen is 3D printed face masks and things like that.
Of course, the ventilators.
Ventilators and all that kind of stuff. So within, I believe, 2 weeks, they had over 1,300 expressions of interest and registrations. And through their system, they've been able to team different manufacturers up to facilitate the manufacture of things such as extra hospital beds and ventilators and things like that. So the opinion that manufacturing is dead or has been dead in Australia, I don't believe it to be an accurate one, but in the eyes of the general public, that is definitely an opinion. And with COVID-19 affecting every country and Australia the way it has done, I think we are going to see a real resurgence in Australian manufacturing. And to get around our high labour costs, leveraging technology is going to be a key way of us achieving that in a sustainable way.
Yeah, absolutely. I think Well, yeah, my hope is that COVID-19 actually ends up being a good thing for New Forge. I don't want to say good thing because it's not quite the right word, but opportunity brings opportunity, and that highlight on Australian manufacturing, and we're kind of not openly or directly, but we're trying to make a focus on Australian manufacturing. Yeah, thank you for joining us, Michael. It's been a real pleasure, and yeah, I love your personal journey from performance Japanese cars now to founding New Forge and doing some really cool stuff with additive manufacturing. Yeah, I'd love to keep in touch and just see how you guys are faring through COVID-19, because I think you're right at that forefront of Industry 4.0, which I think is going to get a real push in the next year. So
yeah, absolutely.
Let's stay in touch. And anyone listening, head over to newforge.com.au. Check out what additive manufacturing really is. It's not the little box on the desk. Well, not entirely. It's bigger and better than that. Until next time. Thanks, Michael.
Great. Thank you very much, Alex. Thank you, John.
And have a great
Thanks
weekend.
For having me. You too. Cheers.
Cheers. See ya.
See you later.
You've made it to the end of another episode of Tech Society. If you're interested in 3D printing and production level additive manufacturing, make sure you hit up newforge.com.au and reach out to Michael and his team. Next episode drops on Friday, where we speak with Dr. Paul Haskell-Dowland, Associate Dean at Edith Cowan University and one of Western Australia's leading experts on cybersecurity. A timely interview in light of recent cyber attacks on the Australian government, so make sure you tune in. Make sure you visit techsociety.fm, sign up to the newsletter, send us a tweet at TechSociety. And as always, Tech Society is sponsored by Ninja Software.